Welcome to Module 16. This module focuses on the spying of web application traffic. As you've discovered in Module 14, which focused on the XSS vulnerabilities, exploiting these flaws could have serious consequences for users of vulnerable services. User data, such as session IDs, could be stolen and malware could be installed on a victim's computer. As you know, it's feasible to execute any JavaScript browser-side. There are also other means of exploiting these holes. Using several simple tricks, an attack is able to write a script which will monitor all operations executed by a web application user, and which will be active as long as a given browser window is kept open. You can see here a simple code for the sniffer. The load sniffer function launches the sniffer. First, it creates a secondary XML HTTP request object used for AJAX requests. Then loads all links and forms in a website. Let's see the sources for these functions. The collect links function is used to load all link tags from the current document and replace target addresses with JavaScript function calls, where the link's URL is the parameter. In the collect forms function, a form's target address is replaced by a function call which assumes the number of the form of the parameter. Let's now take a look at the load URL function. At first, the send-to-attacker function is called, which we'll discuss in a minute. Its source is set to the URL which a user attempted to click, and parameters are set to have the frame fill an entire page. The frame is added to the website's DOM tree, and display delay is set to 400 milliseconds. After this time, the site should preload. The script tag is also added, which loads the code of our sniffer. Next, the load sniffer function is called to parse the page. Let's now focus on the send-to-attacker function. We can see that a referral address is being prepared, which will pass captured data, such as website URL or form content, to our sniffer through the get parameter. XML HTTP request object references to pages from other domains are disabled in virtually all browsers for security reasons. To circumvent this, a script tag is created and the generated sniffer link is submitted as the URL. Next, the tag is added to the DOM tree, so an attempt will be made to load the script, which will execute the GET request and send data to the sniffer. Let's see the sniffer code now. As you can see, all past parameters are logged in the sniffer log file. As for now, the sniffer log is empty. Let's take a look at the source code for our website. In this case, the sniffer's been injected directly into the code, but it's equally probable that an attacker could have inserted it into the service, using the cross-site scripting vulnerabilities. You can see here several links to subpages and a form. The sniffer code is not executed on the subpages. Let's see now how the site works in practice. You can see here the main page. Links have been replaced with load URL function calls. Let's click on the first link. This page has also been parsed by the sniffer. Let's open the second and third links. Now go back to the main page, put a string in the form and try to send it. Let's see the contents of the sniffer log file. As you can see, all calls have been captured, including the values sent through the form. A potential attacker may be able to monitor all operations performed by a victim in this way. Let's try to think of ways in which we could protect ourselves against these attacks. As web developers, we should above all take care of the XSS vulnerabilities. We should also make use of a frame killer. If our page is open in an iframe, the code will redirect an entire browser window to the frame's URL, causing the page to reload outside the frame. In this way, the page outside the frame with all embedded scripts will be skipped. As users, we should be on alert if the address in the bar does not change, even if we have browsed through several pages. What's more, if by hovering over a link we discover that the displayed URL executes JavaScript, we should remain extra cautious. Some newer browsers disable JavaScript access to frames with URLs and domains different than the URL of the window. That's all in this module. Thanks for your attention and see you in the next module where we will focus on session hijacking. Welcome to Module 17. In this module, we'll help you understand session hijacking, which is a type of attack that consists of an interception of a session. Session hijacking attacks allow an attacker to gain unauthorized access to services by taking over the active session of an authorized user. How can this be carried out? As you know, HTTP protocol is stateless. To maintain user state, cookies have to be introduced. Cookies are stored in web browsers and often contain unique user identifiers which are processed server-side to set up sessions containing user information. While an ID is assigned to a specific user, the exploitation of the XSS vulnerabilities we've mentioned in previous modules could allow an attacker to steal a cookie with user session ID to access services. The same could be achieved by using scripts which monitor user actions. Let's see how this works in practice. Take a look at this very simple script. If you visit the admin login PHP URL, the admin variable is set for the current session, which means that the user will have administrator rights. The test PHP file is also available. The file utilizes the PHP session mechanism, and if the admin variable is set, the message hacked will be displayed. The vulnerabilities have been successfully exploited. If this is not set, the message not hacked will be displayed. Imagine that a normal user is being authorized in a service. During this process, a unique session ID cookie is generated and session information is saved server-side. Let's use the Live HTTP Headers add-on to see communications between the user and server. As you can see, once the login PHP address is entered, a PHP SesID cookie is sent to the server. The cookie is used by default to store PHP session IDs. If the administrator falls prey to an XSS attack or data transmission has been intercepted, an attacker can obtain the content of the cookie. Let's open a private tab which uses a new set of cookies, rendering the previous session inactive. Visiting the test PHP URL doesn't give us access to the control panel this time. Let's use the live HTTP headers add-on again. As you can see, a different PHP session ID is sent to the server. The add-on's replay function allows you to freely modify the sent request. We'll set the admin session ID using the cookie we've previously acquired. Next, we send the request to the server using the replay function. As you can see, the access has been granted. How can we protect ourselves against these attacks? The first prevention method is securing the application against XSS vulnerabilities, as these types of flaws might be used to leak session ID cookies used in our service. Using the encrypted HTTPS protocol will guarantee that intercepting cookies won't be feasible outside of the user's computers. You can also add the HTTP-only parameter to cookies, which should disable JavaScript access to cookies. A frequent regeneration of session IDs is also a good idea, especially after a successful login. Another prevention method is checking the IP address related to the session. The address should not be changing while the session is in progress. If it is, this could point to a potential session hijacking event. Many ready-made scripts implement their own session mechanism which checks the IP address used in a session. That's all in Module 17. Thanks for your attention, and see you in the next module, which will talk about session fixation attacks. Welcome to Module 18. In this part of the course, we'll talk about session fixation attacks. Session fixation is a subclass of session hijacking. Session hijacking involves the interception of a victim's session ID. Session fixation occurs when an attacker finds a way to make a victim, who has access to an attacked service, use a valid session ID supplied by the attacker. If the victim assumes the session ID and is correctly authorized in the attacked service, the attacker could take over the session and gain service access. This is possible in the standard PHP session mechanism. If a user has no session history saved in the cookies and the ID is sent through the GET request, it will be adopted as the new session ID. Let's see a sample script which illustrates this scenario. You can see here two files. Admin login PHP simulates the behavior of a script which logs users into a control panel. It sets the admin variable used to identify the administrator in a session variable. Test PHP is the second script. The script checks if the admin session variable is set. If it is, the message hacked will be displayed. If it is not hacked will be displayed. The echo session ID function, which shows the current PHP session ID, is also set for transparency. Let's now see how this vulnerability works. As you can see, a potential hacker wouldn't be able to access the service. The message "not hacked" is displayed. Session ID is also displayed. The ID could also be obtained by using the Live HTTP Headers add-on. As you can see, the same session ID has been set in the PHP SesID cookie. Let's use it now. Assume that a cracker has lured an administrator into clicking on a crafted link. The link looks like this. The administrator has logged into the service, and as you can see, the PHP SesID variable containing the attacker's session ID has been passed in the URL. Let's see what the effects of this are on the attacker's side. As you can see, the attacker has gained service access. How can we protect ourselves against these attacks? Preventing session fixation uses similar methods to those recommended for session hijacking. Above all, it is crucial to recheck a user's IP address and other user-unique data. The frequent regeneration of session IDs, or at least the regeneration of session IDs after successful login, is also helpful. By doing this, we make sure that once a new ID has been generated, the ID known by the attacker will become invalid. That's all in Module 18. The next module will discuss the phishing concept. Thanks for your attention, and see you later.